My name is Peter Bull. I'm one of the co-founders of Driven Data, and we host online data science competitions with a focus on problems that have a social impact. So I'm here to talk generally about data science for social good and a little bit about what we do. So I'm going to start with a picture of a big check, because everyone loves big checks. And this was for the Netflix challenge. I'm sure a lot of you guys know about what the Netflix challenge was. Netflix offered $1 million to a team that could improve their algorithm by 10%. And they put up this challenge in 2006, and in 2009 they paid out to this team. And that was sort of the birth of data science competitions where people were looking to crowdsource algorithms to really smart data scientists. Sort of at the same time, we've seen this explosion of interest and traction in data science for social good projects. And so what we're trying to do at Driven Data is combine those two things. So I'm going to give you guys a couple of examples of the kinds of super cool data science for social good projects that get us excited. So this first one is from the Data Science for Social Good Summer Fellowship that's run out of University of Chicago. And I actually had a good friend that worked on this project. But the basic problem is that the Department of Public Health wants to inspect buildings for lead paint. Lead paint poisoning is really dangerous to infants and expectant mothers. It's highly correlated with learning disabilities and low IQs later in life. And so it's really important that they take preventative measures in structures where they find lead paint. So right now what they had was this state of the world where they had no prediction. They had 200,000 buildings. It would take them 76 years and $100 million to inspect all these buildings. So they asked the data science for social good people for help, and they built them a model, and that's just using characteristics of the building and whether or not they found lead paint during an inspection to create a classification model that targets the buildings you're most likely to have lead paint in. And that gets it down to about 40,000 buildings. It would take 16 years to inspect those and cost about $21 million. However, that's still a lot of time, right? And so the data science for social good people went back to the Department of Public Health and said, we need another piece of data to really make this work. We want to know if you can target where there are expectant mothers and where there are families living with infants, because then we can really improve the quality of predictions. And so they actually hadn't gotten the data yet, but they used a simulated set, and they got it down to about 400 buildings. It would take 2 months to inspect them and cost $200,000. So we think that's a really awesome project. Another one that's super cool is UNICEF's U Report. So in Uganda, the government was looking to have faster responses to crises. They were looking to engage the youth in governmental decisions. And they were looking for broader outreach. They wanted to engage rural communities in these decisions as well. So they created this tool called U Report that was an SMS-based tool that did surveys and feedback. And they sort of asked people, what's the most important problem your family's facing that you want your government to solve for you? And they get back all kinds of answers that sort of fall into these categories and need to be rooted appropriately. Some are urgent, public health crises, water crises, some of the violence categories they need to respond to really quickly. And so they wanted to build a classifier to take these SMS messages and get them to the right people as quickly as possible. And so they worked with IBM on this, and they sort of built this keyword classifier that had an AUC of 71.2. And so then what they did is they took this sort of baseline keyword classifier and they did a couple of really smart things where actually one of the biggest things that was a win for them was just spell checking the messages. They ran a spell checker, put the automatic corrections in, and they added some lexical and semantic knowledge. And they ended up bumping that AUC up to 85.2. And that meant that the people who worked at U Report could spend more time responding to the messages rather than classifying them. One other project that I think is super cool is done by the folks at Datakind. They worked with an organization called Give Directly that gives money to individuals and communities in Kenya. And they wanted to target the individuals and the communities that had the most need. They came up with this really smart way to do this where they look at satellite images of the villages and they figure out whether the roofs of the buildings are made out of thatch or they're made out of iron. and they created this data set where they've had like crowdsourced labeling these, and then they created an algorithm that could automatically look at an image and determine the proportion of roofs that were thatch or iron in a given village, and use that as a proxy for how affluent that village is so that they could target their giving campaigns. If you're like me, you think a lot of these things are super, super cool and exciting. You're an aspiring data scientist, you want to work on these kinds of projects. Often the hardest part is getting a data set and finding a question that's worth asking with it, that's going to be useful to someone. You know, there are a lot of data sets that are out there that people use all the time in teaching machine learning. Like, you know, we saw the iris set like 4 times today already, right? But we think that it's more interesting to learn these kinds of things when you can really engage with the data set and you care about what you're doing. So I'm going to talk briefly about 2 of the friendly competitions that we have up right now. One's about predicting the Millennium Development Goals for the UN. The other one's about predicting whether or not someone's going to donate blood. So the first one, we have this great data set from the World Bank. They track macroeconomic indicators for every country. They have data back to around 1970. And so it's like, I think it's 1,337 indicators, 241 countries, about 50 years. And it's like 15.5 million data points in this data set. And we've picked out the 8 indicators that are related to the Millennium Development Goals. And we've picked the ones for every country. And your task is, imagine that you're in 2007. You have all this time series data from 1970 to 2007 about all these countries. And you want to see what the Millennium Development Goals, how these countries are going to proceed against those at a 1-year time horizon and a 5-year time horizon. So you're making predictions for 2008 and 2012. And you sort of want to pick out these correlations between the macroeconomic indicators that represent a goal and the other indicators you have that are representing other things that are going on in these countries. And so that's the first one. The second competition we have up right now is about predicting blood donations. This is sort of like a very simple, just for fun kind of problem. The data is from the UCI machine learning repository, which has a lot of really awesome data sets for learning, but it's only about 700 rows. So it's a fun one to get started with if you're just sort of like building your skill set right now. You can go in, you can do a basic binary classification. But one of the exciting things about it is the problem's kind of cool. They had this mobile blood donation van in Taiwan that would go around to university campuses and get blood donations, and they have histories of donors over time. They need to know how many people they expect to donate next time the van comes around. And so they wanted to predict how many of the donors that they have history on are going to give when they come back the next time they come to campus. And so that's the goal of that data set there. So just a little bit about our site now. So this is a screenshot from our leaderboard from earlier today, I think. You know, membership is totally free. You sort of get feedback in real time about how your algorithms are performing against other people. The organizations that are supporting this work see that they're getting a variety of approaches, and that heterogeneity means that they know they're getting a high-performing solution. And also, shortly we're going to start offering prizes for the top solutions. So we have 2 competitions upcoming in the next month or so that are going to have cash prizes. One is in education and the other one's in microfinance. And the other great thing is you get to be part of a community of other like-minded data scientists. So that's what Driven Data does. You can check us out at drivendata.org, tweet at us, drivendata.org. We're built in Python and Django. We do all our analysis in Python, so if you want to talk about those things, Greg and I are around for the rest of the day. And yeah, please come say hi and, you know, log onto the site, compete, win some money, and do some good.